Welcome back to the channel. In today's video, we will be solving an interesting problem that frequently appears in coding interviews, determining if a number is a power of 2. Over LeetCode, it is present with the name power of 2 and is described as given an integer n, return true if it is a power of 2, otherwise return false. An integer n is a power of 2 if there exists an integer x such that n is equals to 2 to the power x. Now, what does it mean? We are given an integer n. We have to return true if it is a power of 2. Otherwise, we have to return false. Now, here three examples are given. In example 1, input n is 1 and output will be true because 2 to the power 0 is 1. Now in second example, n is 16 and we know that 2 to the power 4 is 16, so the output will be true. In third example, n is 3 and we know that 2 to the power any number is not equals to 3, so the output will be false. Let's now try to understand what does this problem says. According to LeetCode problem, we are given a number x, suppose we have 16. And now we have to return true if this number can be represented in the power of 2. We know that 2 to the power 4 is 16. So we can see that this 16 can be easily represented in 2 to the powers. Here 2 to the power 4 is equals to 16. So the output for this will be true. But now assume we have another number x is equals to 17. Now we cannot represent this 17 in the powers of 2. So this 17 is not the power of 2. So we will return false here. Now the problem is this here is how we can check if the number is power of 2 or not. For that we need to find the prime factors of the number. Here the number is 16 and if we find its prime factor, they will come out to be 2, 2, 2 and 2. Now if all the prime factors of the given number are 2, then it will be in the power of 2, otherwise it will not be the power of 2. Making this process more simple and easy, we can do one thing like we have given the number x is equals to 16 and we will divide it by 2 a certain number of times, and if we gets 1 after dividing it by 2 a certain number of time, then it will be a prime factor, it will be a power of 2, otherwise it will not be the power of 2. Let's suppose we have the number 16 and we divide it by 2, it will result in 8. When 8 will be divided by 2, it will result to 4. 4 divided by 2 result to be 2, and 2 divided by 2 the result to be come out to be 1. We can see that after a certain number of divisions by 2 we gets the result to be 1. Now, so that we can say that this number 60 be represented in the powers of 2. It is very simple and we can solve it by using a basic while loop. We can see that the 16 can be represented in the powers of 2. This is the basic and very easy approach how we can get to know if a number can be represented in power of 2 or not. The problem here is that it have a time complexity of big O of log of n. But we are asked to solve it in a big O of 1 time complexity. So let's try to optimize this time complexity, big O of log of n, to achieve our goal. Here I have took a few of the numbers which can be represented in 2 to the power something, and I have written their binary. The thing you can observe from here is that the binary of all of these numbers is always having only a single one. present in somewhere in that string. So now suppose we have 16, it can be written as 16 in binary 1 0 0 0 0. We can see that it have only 1 at this place. And now if we write the binary of its preceding number, that is 15, then we can see that its binary will be equals to 0 1 1 1 1. Now the thing we have observed that if a number is in the 2 to the power of something and we write the its binary and we write the binary of its preceding number, we apply the binary and that is the binary and that is bitwise, and in between these two numbers we will always get 0. So this is how we are going to solve this problem. We will apply the AND with in between the number and with its preceding digit, and if we get 0, then it is the number which can be represented in 2 to the power n. The time complexity in this case will be big O of 1. So let's try to code for this.